Okay, in this video we will solve homogeneous linear equations by getting eigenvalues and eigenvectors. So we want to solve x prime is equal to ax, where a is denoted by this 2 by 2 matrix. So 1, 3, negative 2, negative 4. And so what we do to get eigenvalues is say this is going to be 1 minus r, this is going to be negative 4 minus r, and 3 and negative 2 will remain the same. And this is going to equal 0. So next we multiply this out, and we're going to get negative 4 times 1 is negative 4. Negative r times 1 is negative r. Negative 4 times negative r would be plus 4r. Negative r times negative r will be r squared. And then we do minus parentheses 3 times negative 2. So minus times negative 6, so plus 6 is equal to 0. And so now we want to group everything. So we have r squared plus, so 4r minus r would give us plus 3r. 6 minus 4 will be plus 2 is equal to 0. And we can factor this out by saying parentheses r plus 1 times r plus 2 is equal to 0. And so our eigenvalues will be r is equal to negative 1 or r is equal to negative 2. And so the next thing that we're going to do is do both of these eigenvalues. So we'll say 4r is equal to minus 1. And so what we're going to do here is plug minus 1 for r. And so we would get 1 minus minus 1 is going to give us 2. 3 remains the same. Negative 2 remains the same. Minus 4 minus minus 1 will give us minus 3. And now we want to kind of clear one of these terms out if we can. We can do that by saying that r2 is equal to r2 minus 3 half of r1. And so that's going to give us 0, 0. What we're doing here is called row reduced echelon form. And next we want to even simplify this a bit. So we can say that r1 is equal to 1 half r1. And so we would get 1, negative 1, and 0, 0. And so we can say v1 is equal to minus parentheses minus v2. And so v1 is equal to v2. And so if v2 is 1, then v1 is 1. Or if v1 is 1, then v2 is also 1. And so we say that this right here is an associated eigenvector for r is equal to minus 1. And next we do the exact same thing for r is equal to minus 2. So we plug in minus 2 for r, we plug in minus 2 for r, and we would get 1 minus minus 2, so 3. Minus 2 remains the same, 3 remains the same, and minus 4 minus minus 2 will give us minus 2. And we do the exact same thing as this. We do row reduced echelon form, and we can clear it out by saying that r2 is equal to r2 minus r1. So 3 minus 3 is 0, minus 2 minus minus 2 is also 0. And so we get this form. And next we will say that 3v1 is equal to minus parentheses minus 2v2. And so 3v1 is equal to 2v2. And so if we plug in, let's say 2 for v1, then v2 has to be 3. Because 3 times 2 is 6, 2 times 3 is 6. So this would be this. So v1 is 2, and v2 is 3. And we say that this is an eigenvector associated for r is equal to negative 2. But now we want to solve x prime, like we want to solve this. And so we say the general solution would be denoted by x vector is equal to c1e raised to negative t because our two eigenvalues were negative 1 and negative 2. So negative t is because we have negative 1 for 1. Then we do this this eigenvector of 1, 1 plus c2e raised to negative 2t because this eigenvalue was negative 2, so negative 2t, and the eigenvector for it was 2, 3. And so this is our final answer for the general solution. And that's all we need to do for this problem.